Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if your phone is secretly telling us more about you than you realize? Well, this new study dives deep into how our phones can give us psychological insights. Today, we're talking about making sense of all that digital noise we create with our smartphones. Researchers are finding ways to turn the data from our phones into clues about our minds. It sounds like science fiction, but it is happening now. Think about it. For years, psychologists relied on questionnaires to understand us. But questionnaires are like a snapshot, a quick look. Smartphones, though, are with us constantly tracking our every digital move. This paper is all about how scientists are taking all that constant phone data and figuring out what it can tell us about our psychology in a super detailed way. For a long time, if a psychologist wanted to know how you behave, they'd ask you. But asking can be tricky. People might not remember exactly, or they might say what they think is expected. Now with phones, we can actually see what people are doing in their real lives without badgering them. This is called mobile sensing, and it's a game changer. Phones are amazing because they can do this passive tracking and can also ask us questions through apps like what they call Ecological Momentary Assessments, or EMAs. This new field is called digital phenotyping. It is like giving behavior a digital fingerprint. This paper is focusing on app usage logs from smartphones, which is a goldmine of information. But there is a problem. This data is messy, it's huge, and it's complex. So the big challenge is how to clean it up and make it useful. The researchers here are showing us how they build these smart pipelines to do just that. So how did they get this data? They used a study called the Smartphone Sensing Panel Study. They had people download a special app called PhoneStudy on their own Android phones for 3 to 6 months. This app was secretly collecting all sorts of data about how the phones were used. It also sent out those EMA surveys sometimes. They collected data from 850 people, and for this particular study, they focused on data from about 538 participants. This data included things like when the screen was on or off and exactly which apps were used and for how long. They also collected location data from GPS and those EMA Self-Reports about feelings and situations. Imagine your phone's activity log. It's a stream of time-stamped events, for example, the screen turning on or off or opening an app like Facebook. Table 1 shows a simplified version of this raw data. You see the timestamp, the type of activity like GPS or apps, and then details like the app package name or GPS coordinates. App usage itself generates tons of these time-stamped events. When you open an app, navigate within it, and then close it, that's a whole sequence of signals. This can get confusing though. Sometimes opening a part of an app counts as a new launch. Also, the phone itself does things in the background that create logs too, like managing battery or network. So you can't just count launches. You have to define what a real app usage session is. This is where the pre-processing begins. Before any analysis, the data needs cleaning. The first step is to define these app usage sessions properly. The researchers built a rule-based function to figure out when one app session starts and ends. It looks at when an app is launched and when another app is launched or the screen turns off. This creates a cleaner summary table of each app usage session, with start and end times and the app name. Table 2 shows this cleaner summary. Each row is a distinct time you used an app. It tells you which app, what time it started and ended, and how long it was used. They also add extra labels like app category, for example, social media or communication, and whether you were at home or not at home based on GPS data. Plus, they link it to EMA data. Now, to make this data even more useful, we need to enrich it. Data enrichment means adding more context. This can come from external sources like categorizing apps into groups. Instead of just looking at Facebook usage, we can look at all social media usage. They used a system that categorizes apps into 26 psychology-friendly groups. This helps because not everyone uses the same apps. For example, only about half the people in the study used Facebook or Instagram. But almost everyone used at least one social media app. Grouping them makes the data less sparse and easier to analyze. It also makes the findings more psychologically interpretable. Instead of saying people who use Facebook a lot, we can say people who use social media a lot. This even applies to things like GPS data. On its own, a GPS coordinate doesn't mean much. But if we add information from a map service telling us it's a restaurant or a park, then it becomes meaningful. The next big step is data aggregation. This is like summarizing. We take all those individual app usage sessions and condense them into more meaningful behavior variables. For example, how often did someone use social media, per adult and why? Or how long did they use it? You can aggregate this over different timeframes like hourly, daily, or the whole study period. Table 3 shows some of these aggregated statistics. For example, it shows the average daily number of app usage sessions and the average duration. It separates this by app category like social media or communication, and by location, like at home or away. Now let's look at some more advanced ways they use this data. Case 1 is about data integration. This means combining different types of phone data to get a richer picture. They combined app usage data with GPS data. Their question was, how does our social media and communication app usage differ when we are at home versus when we are out? This is important because behavior might change based on our surroundings. For example, using social media more at home might be linked to feeling less well. To do this, they first had to clean up the GPS data. GPS data can be a bit jumpy. So they used a method called dbScan, a clustering algorithm, to identify key locations like home. They figured out where people spend the most time between 1 a.m. and 5 a.m. and called that home. Then they labeled all other GPS points as not at home. They then combined this location info with the app usage data. They added a location category to their app usage sessions. If an app session happened when the phone was labeled at home, it got that tag. They found that people used social media and communication apps more often and for longer periods when they were at home. This kind of contextual information is precious. Case 2 gets even more interesting. It's about integrating data using statistical models. They combined app usage with EMA Self-Reports. Remember, EMAs are those in-app questions about how you feel or what you're doing right now. Their question here was, how does our perception of sociality in a situation relate to our app usage during that situation? For example, if you're using social media, are you feeling more social or less social? They wanted to see if they could link the objective behavior of using an app with the subjective experience of feeling social. They also looked at how stable your perception of sociality is over time. To do this, they looked at app usage in the 60 minutes around each EMA question. This way, they could directly link the app use to the feeling reported at that specific time. They used statistical models to see if longer durations of social media or communication app use predicted feeling more or less social. They used two approaches, a nomothetic approach, which looks at general patterns across everyone, and an idiographic approach, which looks at patterns for each individual person. This fancy equation here basically represents a statistical model. It is trying to understand how app usage predicts your reported feeling of sociality, while also accounting for individual differences between people. They found that overall, more social media use was linked to feeling less social. This is a really nuanced finding because it connects objective phone data with subjective feelings. Case 3 is perhaps the most futuristic. It's about data substitution using predictive modeling. The idea here is to predict EMA responses from passive phone sensing data. Why would we want to do this? Because answering EMAs can be a burden for participants, especially in long studies. If we can predict those answers from phone data, we might be able to avoid asking so many questions. For this case, the researchers focused on sleep. They know that using apps before bed can affect sleep. So their question was, can we predict sleep duration and how rested you feel in the morning just from your app usage the night before? If they can do this, they could use their phone data to estimate sleep quality without needing you to fill out a sleep diary every day. They collected app usage data from the 3 hours before people reported going to sleep. They then used this data to train a machine learning model called a random forest. This model learns the patterns between app usage and the reported sleep outcomes. They then test how well the model can predict sleep for people it hasn't seen before. Unfortunately, in this specific study, the random forest models didn't perform very well. The predictions for sleep duration and morning relaxation were actually worse than just guessing the average. The researchers talked about why this might be. One reason is that self-reported data itself can have errors or be unreliable. Also, app usage data can be sparse. Sometimes you might not use apps in certain categories for hours. This makes it hard for the model to find strong patterns. They think that using more data across different sensing modalities, like combining app usage with physical activity from wearables, might lead to better predictions in the future. So what is the big takeaway from all of this? This paper shows us that mobile sensing data is incredibly rich and can provide deep psychological insights. The researchers highlight two key processes data enrichment, which is adding context and data aggregation, which is summarizing data. They show that there is no single perfect way to do this. The best approach depends on your research question. But the more complex you make your pre-processing pipeline, the more decisions you have to make. This means researchers have a lot of freedom, and that can be a challenge for making sure research is reproducible. They emphasize the importance of being transparent about all the steps you take. They also point out that the temporal resolution of data is really important. We can not only look at daily averages, but also at very fine-grained changes over time to understand behavior patterns better. And the sheer amount of data collected means high dimensionality, which can be a challenge but also an opportunity. They suggest future work could even use advanced methods like neural networks to find hidden patterns in raw app usage events. This research is about making sense of our digital lives. It shows that our smartphones are not just communication tools, but can also be powerful instruments for understanding our minds. By carefully cleaning and analyzing this data, researchers can uncover subtle behavioral patterns that we might not even be aware of ourselves. While Case 3 didn't perfectly predict sleep, it highlights a really important goal: reducing participant burden and getting more objective insights. What I find most exciting is how this research moves us beyond simple self-reports. It allows us to study behavior in its natural context without interruption. Imagine understanding someone's personality not just by what they say they do, but by how they actually use their phone throughout the day. The potential for mental health research for studying personality for understanding everyday behavior is immense. Of course, there are limitations. As we saw, Case 3 shows that sometimes the data doesn't give us clear answers and more work is needed. Also, privacy is a huge concern, which is why the raw data can be shared. But the researchers are sharing the processed data and the code, which is fantastic for transparency. Ultimately, this paper is an invitation for psychologists to embrace these new tools and develop innovative ways to analyze them. It's about asking more nuanced questions that sensing data can help us answer. Like, how do specific app interactions influence our mood throughout the day, or how does our mobility pattern relate to our social connections? This is just the beginning of understanding the psychology of our digital footprint. So what do you think? Has this gotten you thinking about your own phone usage? Let me know in the comments below. And if you found this breakdown helpful, please hit that like button and subscribe to RUBIN'S Mind Lab for more explorations into the fascinating world of psychology.